So hello everyone, I am Hemant Shinde. Today we are going to discuss about one assignment from LP2 Laboratory Practices 2 regarding the text mining. So the problem statement of the assignment is that what we have to do, we have to consider the suitable text data set, we have to remove the stop words, apply the stemming, and we have to use a count vectorizer and the TF-IDF vectorizer, and we have to find out the precision, recall, and the F1 score. So before taking a particular data set, we need to discuss about what exactly the stop words. So stop words is the commonly used words such as the, and in that search engine has programmed to ignore both when indexing the entries for searching and when retrieving them as the result of search query. So for that purpose we have to use the NLTK library. So for example, what would be the stop words? If I take the sentences as I like reading, so I read, so it will remove I, so I, and it will only keep the words like, reading, read. So NLTK provides the separate, we can say there are the NLTK is a library provided by the Python, with the help of which we can do the text processing. So second part, after removing the stop words, what exactly the stemming? So stemming is the process of reducing the inflection in the words to their root forms, such as mapping a group of words to the same stem even if the stem itself is not a valid word. So stemming is in simple words, stemming is nothing but what we are doing, we are bringing that particular word to its root form. For example, playing, so it is having ing as its suffix, so we are going to remove that particular suffix and we are bringing that playing word to play. So it will be better for the machine learning algorithm to analyze that particular word. So for example, playing, plays, played, so these are, we can say, the actual words and their stem words, so the root words are nothing but the play, play, play. Am, is, are, is to be replaced by the be. Now we are going to discuss the same with the help of the programs. So for that purpose what we have to do, so I have opened this particular Jupyter notebook. It's loading. So what we have to do, first of all we have to install the pip install NLTK. So on my machine I have already installed it. After doing installation, you can check whether it is successfully installed or not. For that purpose, nltk.download, so it will return you the true. So from nltk.corpus we have imported the stop words. Then from nltk tokenize, word tokenize, and porter stemmer. So porter stemmer is a class that we are going to use for the stemming purpose, and word tokenize we are going to use that particular to convert our text data into the tokens. And we have used the from sklearn feature extraction.text, we are importing the count vectorizer. So we have considered the text as programmer text. We have simple text that we have considered is a programmer writes program on the business warehousing. Now in this particular, what are the different stop words? So stop words are on is the only stop word that is available with this particular text. So how to remove that particular? So stop words is equal to set stop words dot words English. So we are printing the stop words. So these are the list of stop words that are available in your English language provided by our, we can say, the Python NLTK library. So that is doesn't, there, wasn't, doesn't, your, that, before, up, other, for, been, we, few, two. So these are the her, his, all these are considered as a stop words which don't have any meaning, we can say, while processing the text data. So next is the word tokens. We are going to convert that particular with the help of this word tokenize. We are going to convert the given text into the tokens. So when we execute this, so it will look like word tokens. So I am. So when we take a particular, we can say, okay, so for that purpose what we need to do, we need to import all these, because this is a Jupyter, so every time we have to load all these particular. So for that purpose what we have to do, we have to import all these again. So this particular thing is going to execute. So this also can be elaborated with the example. Okay, so here so we have imported all these particular required, we can say, the libraries from the Python NLTK. So stop words we have, then word tokenize here. So our text is programmer writes program on the business warehousing. So what are our word tokens? Programmer writes program on. So we are dividing each word into the, we can say, the tokens. Now filter token. So what is filter token? So after removing the stop words, whatever the words that we will receive, that will be called as a filter token. So for that purpose what we had done, we had write the for loop for w in word tokens from the list of tokens. What we have, if w not in the stop words, then we will add that into the filter token. So when we will run this particular, so see the output. Now here our word tokens are programmer writes program on business warehousing, whereas the filter tokens are, so this particular stop word on, that is removed from the filter token. So programmer writes program business warehousing. Now after removing the stop word, the next step is the stemming. So what exactly the stemming is? So stemming is we are bringing that particular word to their root word. So removing the prefix and the suffix. So for that purpose we are using the ps is equal to porter stemmers. We have created this particular class and the stems token to store the root of form of each word. But there is a problem with the we can say the stemming process, because it can bring the word to the any word which don't available with your even in English library sometimes. So for that purpose the lemmatization is used. We can have some it will bring the words to their dictionary meaning. So we have used the filter tokens. Now see here, see the output. Programmer is our word. So, here programmer is our word. So its root word is program. Writes, write, program, program, business, business, busy, warehousing, where. So it does not that is a drawback of the stemming process or the porter stemmer, is that it does not bring to the meaning, we can say, the meaningful data. So the next part that we are going to discuss is the count vectorizer and the TF-IDF vectorizer. So for that purpose we have considered the two text and text one. So text is data mining is good domain for the research. Text one is we are studying data mining today. So we have initialized these two particular text, then we have created the object of count vectorizer and we are displaying that particular. Now see here, vectorizer dot fit text print count vectorizer. So data it occurring in that particular text, it is occurring 1 times here. Data mining is good domain for research. So how many times data is occurring? Data is occurring once. Mining is good domain. So it is occurring once in both the, we can say, the research. So it has, we can say, the give the, we can say, indexing to it. Now second thing is that, so this particular can be elaborated. Count vectorizer and the TF-IDF vectorizer can be elaborated more with this particular example. Now see here, we have imported the count vectorizer and the TF vectorizer from feature extraction dot text. So it is executing. Then for that purpose, what we will do, we will load the, this particular function into the main memory, and we are considering the, this is our message 1. So my name is XYZ. This is our, we can, for simplicity, we are considering this as one document. Please subscribe to my YouTube channel. That is second, we can say, the document. So it is taking time to execute. Once it will get executed, then we can go further. So this star indicate that these two cells are still in execution mode. They have not yet executed. The next part is create document term matrix. So what exactly the, till time you can go ahead. So what is this particular term frequency? So term frequency, that is TF of ij is number of occurrences of a word I in a given document divided by total number of words in a given document. Term frequency, that is, we can say, we are counting its frequency, whereas IDF, inverse document frequency, we are suppressing. If the particular word is occurring many times in the document, so we are suppressing its weightage by taking its IDF value. Okay, so that would get executed. See here, these two cells get executed. Now we have created this particular count vectorizer, create document count vectorizer. Now see here, what was our message? We have passed the message 1, that is, my name is XYZ. Please subscribe to my channel. So what it does, it has created its, we can say, the list of corpus is created, and the duplicate words are removed. Now is occurring once, my is occurring twice, so it took at only one. So channel is my name. Please subscribe to my XYZ YouTube. Okay. Now here this channel is occurring 0 times, is occurring 0 times. So likewise, it has mentioned that particular, taken its this particular 0 indicates this is first document. My name is XYZ. So in place of my, it will put 1, name it will put 1, age it will put 1, and XYZ it will put 2 and 1. And this is, we can say, the 1 second. Please subscribe to my channel. So these words are occurring in the second document where it is. So it has mentioned its frequencies. Now second, when we will put the second message to ABC is my name, ABC likes Python programming, and when we will call this particular TF-IDF vectorizer. So here ABC is language, so it gives, we can say, the TF-IDF score of this particular first document and the second document. Now ABC is occurring only in, so it has, we can say, the highest. Now if the ABC is occurring many times in first and the second document, then how it will suppress its, we can say. So this is, we can say, all about your process of TF-IDF and the count vectorizer. Now for the our test purpose, we have used the, we have load the here from sklearn, feature TF-ID vectorizer.